Hello everyone, I'm just going to go through example 3 and 4 from yesterday's lesson that we did not complete in class for those of you that want to see solutions to them. The first example, number 3, asks us to sketch a cosine function over 2 periods, and we're also asked to state the amplitude, the period, the phase shift, and the vertical displacement. We can do this in any order we want. The bottom line is you're going to have to compare that function given in the question, this function, you're going to want to compare that to the general cosine function that appears on your formula sheet of y equals a multiplied by cosine of the entire quantity of b times x minus c, and then plus d, for you to determine the parameter values of a, b, c, and d. It's those parameters that's going to tell you the different features of the graph and how we can sketch it and how we can determine the phase shift and all of these other characteristics of the graph. So if we look at a is -2. When you compare the function given highlighted in blue to the red function written out, which is the template, you can see that the coefficient of x, which is in this case is theta, is 1. That means b is equal to 1. We can see that c has a value of -2 pi over 3. And the value of the parameter d is -1. So I'm going to start off with the final parameter d. If d is -1, that means the vertical displacement is -1. And what that means is that the center of this graph that separates the top and the bottom portions of the graph, which would normally be on the x-axis, is going to be shifted down 1. So when we sketch this graph is going to oscillate vertically above -1, below -1, above -1, below -1, etc. If we take a look at the parameter a has a value of -2, and what that means is that the amplitude of the graph will be 2. Remember that the amplitude, I'll write that here for us to see, the amplitude is always the absolute value of the parameter a. So if a is -2, the amplitude is 2. And that's valuable in terms of graphing the function as well, because if the amplitude is 2, that means that the graph is going to go 2 above the middle, which I've highlighted with that brown dotted line, that also known as the vertical displacement, and it's going to go 2 below the vertical displacement. So now we get more information about the graph. Whatever we draw is going to wobble up and down between -3 and +1. In other words, if we wanted to know the range at this point in time, we could state the range as being -3 is less than or equal to y, which is less than or equal to 1. If you were asked in a question on an exam what is the maximum value of this function, you can figure out that the maximum value is the vertical displacement plus the amplitude, and the minimum value, if you were asked, is the vertical displacement minus the amplitude. What else is going to be helpful in us graphing this? Well, we're going to need to know the period. But remember, and I'll put this down here in the same kind of place I put the formula for amplitude, period is 2 pi, the regular period of cosine, over b. More specifically, the absolute value of b. But since b is 1, what we're talking about here is a period of 2 pi. And if you want to take a stretch approach to this explanation of why the period is 2 pi, the period of y equals cosine of x is 2 pi, and if b is 1, that graph of cosine of x has not been stretched horizontally at all, which means the period is not going to change. What about the phase shift? Well, the phase shift is the value of c, which is -2 pi over 3. Now, this is very important because when we talk about sketching trigonometric functions that are sine functions or cosine functions, what we always have to do is consider where the start point of the function is. And just to go back and review sine and cosine functions with you, if I take a look at the sine of x as a graph, and I'm going to choose zoom trig, this is the graph of y is equal to sine of x. If I wanted to look at the graph of y is equal to cos of x, I could use my calculator. You know, the hope here is that you don't have to use your calculator in order to understand what these look like. But what I'm saying is, in order for me to show them to you, this is probably the quickest way to do it. And if you're ever stuck on an exam, you start to sweat during an exam and you panic, you could always use your calculator to remind you of what these graphs look like. When we talk about the start point in Math 30-1 of a trigonometric function, what we are referring to is where the graph would normally start when you look on the y-axis. And sine of x starts at the origin, or the middle, going up. Cosine of x starts at y equals 1, or the top, going down. So whenever you have a sine function, the start point is normally in the middle and it moves up. When you have a cosine function, the start point is normally at the top and it goes down. How is that helpful here? Well, what that's telling us, since this is a cosine function, is that the graph would normally start at the top and it would normally move down. But because A is negative, there's a vertical reflection. And that vertical reflection is across the x-axis before everything is translated up or down. And the result is that if you were to reflect cosine of x across the x-axis vertically before things are shifted around, then after things get shifted around, the start point becomes at the bottom, moving up. So the start point that I've drawn and the general shape of the curve that I've drawn in brown, it would be the start point if the parameter a was positive. The start point that I have in red is the result of the parameter being negative for cosine. However, we have another issue, and the other issue is that the graph has a phase shift. The phase shift is negative 2 pi over 3. Now, all a phase shift is a horizontal shift. So that means that the start point is going to be at the bottom moving up, but it's going to be 2 pi over 3 to the left of that red curve. Now we have to figure out what 2 pi over 3 is. Well, when you look on the x-axis, pi is 3 squares, so 2 pi over 3 is 2 squares. Each of these squares, this one, and this one, is pi over 3. So 2 pi over 3 is 2 of those squares. The start point then is going to be here, moving up. And I don't know that I've drawn the red curve to the right scale. This is just indicating that that's where the start point will be, and it will be moving up. All of this other stuff I'm going to erase because that was just us thinking about what's going on. Now, we have one more thing to do before we can finish this problem, and that's to remember that a cosine function, or a sine function, goes through a complete cycle in the period. And in a case of a cosine function that starts at the bottom going up, it is going to go from the bottom, and I'm going to draw this on a separate page. It is going to go from the bottom, it's going to go up to the middle, up to the top, down back to the middle, and down to the bottom. And this total distance, horizontally, which covers these 4 sections, is the period of the function. So we have to draw this series of 4 curves connected together over the period, and we were told the period is 2 pi. Well, we weren't told that, but we figured out the period is 2 pi. So what is 2 pi? Horizontally, 2 pi is the distance from here to here. It's 6 squares. And you're not necessarily going to draw everything I'm putting on the screen. I'm just doing that to show you that this distance down here is going to be the period. The period will be the distance between these 2 points. So the graph has to start at this point that I'm going to put a green dot in the center of. It has to finish over here at this point that I'm going to put a green dot in the center. It has to go up, up, down, down. So now what you're going to do, and I can get rid of this line, it's really just getting in the way. Now what you're going to do is split up that period, split up those 6 squares into 4 equal pieces. So when I look at the top of my screen, it starts here, it finishes here, halfway in between is there, halfway in between again to get quarters is here and here. So the graph has to go up to this point, covering a quarter of the period, continue up to this point, covering the second quarter of the period, move down to this point in the next quarter, and to finish off, the fourth quarter will end here. And again, this red curve that I've drawn, this one here, was just to show you that it has to start at that point going up. I really don't want it on there. Now I can draw my graph. Again, you're not necessarily an artist, but you have to. I think you're more successful if you don't try to draw this as one big wave, but you draw it as 4 pieces. We are asked to do this for 2 complete periods. You can see that a quarter of the period, there's a quarter, there's a quarter, there's a quarter, there's a quarter. A quarter of the period is a square and a half, so I could continue moving horizontally over a square and a half and up, continuing up and moving over a quarter, which is a square and a half, moving down. Another quarter is produced by moving over a square and a half, and then finally we finish here. And I can sketch up, up, down, down. So we can check something out here just to confirm for you visually. If I were to look at this piece here, I should be able to take that and just slide it over and it will fit nicely here, and it does. So we've graphed the function. I suppose what we could do, just to be clear, is put arrows on the ends of these to indicate that it goes on. But we've graphed the function, and then we've listed all of these properties that we were asked to list. Let's take a look now at example 4. 4 gives you a graph and asks you to find the equation of the function. Now, 4a says we want a sine function, and we are forced to use a positive value of a. So you're not allowed to be clever in this question and use a as a negative number, which might make your job easier in some cases. The first thing we're going to do is figure out what the values of a and d are. A and d are the vertical parameters in trigonometric functions, and they are determined by looking at the middle of the graph, which would be here. And all I did to determine the middle of the graph, I actually imagined the maximum here first and the minimum here second, and I said, where is the middle going to be? And I counted in my head that the difference between the maximum and the minimum is 6. It goes from -2 up to +4, that's 6. So that means the middle is 3 below the maximum and 3 above the minimum. What does that tell me? That tells me that a is 3, and we are told we have to use a positive value of a. The reason a is 3 is the amplitude of this graph, which is this distance, is 3. And we can see that d is the vertical displacement, the middle of the graph, which is at 1. Now what we're going to do is we're going to determine b. We're going to determine b by remembering that the period of the graph is equal to 2 pi over b. which means that b is equal to 2 pi over the period. The question was asked yesterday in class, when you're trying to find the period from a graph, is it better to use the formula that I've written on the bottom of the screen rather than to try to think about stretches? And again, the answer is it's entirely up to you. But what I'm going to do is go back up to the graph and look at a period of this graph. I know it's sine, but I'm still going to figure out the period by looking at from here to here, which is up, up, down, down. And I can see that the period is the distance from this point to this point. This is the period. And now I have to look at the axis and figure out what that number actually is. That is 4 squares out of 6, which takes us to pi. So it is 4/6 of pi, or 2/3 of pi. And we can use that now to figure out what b is. B will have a value, we don't really need the absolute value here, but B will have a value of 2 pi over the actual period, which is 2 pi over 3. If I multiply the top and the bottom of this by 3, I'm going to end up with 6 pi on the top and 2 pi on the bottom, because the bottom two 3's cancel. And the pi's now cancel, and the 6 over 2 is 3. So I know that b has a value of 3. And now we have to determine c, and then we're done. And this is the most difficult thing. What we are going to do, and I'm going to do a bit of erasing here because this is just getting in the way. This is just part of my explanation. What we're going to do is graph this sine function with the parameter of a equals 3, and ask ourselves if it matches the graph that we're trying to determine the equation of. Well, the start point of sine is always in the middle, going up. And since a is positive 3, there's no vertical reflection. So that means with all of these parameters, our graph will start here going up. But that's not where we want the graph to be. We want to find the equation of a graph that starts here going up. So the red graph is the graph basically with no phase shift. And the graph with no phase shift is not what we want. We want a graph that matches the green graph. The question is, what can we do to that red graph to get the green graph? And the answer is we have to shift that red curve to the right pi over 6. And that means that c is going to have a value of positive pi over 6. And now we can write out the equation of the function. The function will be y is equal to a, which is 3, multiplied by the sine of b, which is 3, times in another set of brackets x minus c, which is pi over 6, close brackets, plus d, which is 1. And if you were to graph that on your graphing calculator and put your graphing calculator in radian mode, you would see that the graph matches the graph we're looking at. Now, when we take a look at 4b, the fact of the matter is a is still going to be positive 3. And d is still going to be positive 1. Because it doesn't matter how you cut it, whether it's a sine function or a cosine function, the middle of the graph is at 1. That's the vertical displacement. The maximum of the graph is at 4. The minimum is at negative 2. The maximum is 3 above the vertical displacement. The minimum is 3 below. So those two parameters are still the same. Similarly, we don't have to go through the process of calculating the value of b again, because it's the same graph. So whether it's a sine function or a cosine function, the fact of the matter is the period is the same. the period of this graph we decided was 2 pi over 3, and we used that 2 pi over 3 to determine that b was 3. The only problem now is, what is c? Well, we're going to do the exact same thing we did in question 4a. I'm going to look at the start point of cosine. Cosine normally starts at the top and goes down. And since a is positive, this graph has not been vertically reflected, which means the start point is going to be at the top and it's going to be moving down. And that would be with no phase shift. That would be with c equals 0. That would be what the graph would start to look like when c is 0. But we don't want that. What we want is a graph that starts here going down. So that means we have to take that red graph and shift it to the right to match the graph that we are after. And the question becomes, how far do we have to shift it to the right? Well, you have to shift it 2 squares, and that's 2/6 of pi. Each square is pi over 6, and that means we have to shift it pi over 3 to the right. So c has a value of pi over 3. So now we can write out the equation of the graph. As a cosine function, it's y equals a, which is 3, times cosine of the entire quantity of b, which is 3, times x minus c, which is pi over 3. Close brackets on that entire argument. And then we have to add d. So that's the equation of the cosine function. So I'm going to put my calculator in radian mode. I'm going to actually set up my window settings manually here. When I take a look at the picture on the screen right now in terms of the scale, it goes from essentially negative 2 pi, not exactly negative 2 pi, but it goes from about negative 2 pi to 2 pi. Horizontally, that's the scale, or the window settings. Vertically, it goes from negative 3 to 5. I'm going to enter in the function that we created, which is at the bottom of the screen. Y equals 3 cosine of bracket 3 times in bracket x minus pi over 3. Close the brackets on both of those arguments and add 1. And it looks pretty good. You could, of course, go to your table or start calculating some points, max-min points on your calculator, or looking at your trace function to prove that that's the same graph. But you will discover it is. If we were to enter the sine function we got, which was at the top of the screen, I'm going to put that as y2. 3 sine, and then 3, another set of brackets, x minus pi over 6. Close the brackets on both arguments, add 1. And I'm going to scroll to the right here, sorry, to the left, and change this function to be graphing what I call the bouncy ball. And I hit graph, and you can see that it matches the other graph perfectly. So for those of you that wanted to see examples 3 and 4, there they are. I hope you have a great day, and we'll talk to you later.